How to merge tables with Autonumber primary keys referenced by foreign keys. In this video, we are going to talk about a pretty common task to combine data from two relational databases when this data is using Autonumber primary keys referenced by other tables. Such relations are often called parent-child relationships, and our task can be demonstrated by this picture. Let's say we have two databases, SourceDB and TargetDB. Each has two tables, parent and child. Both use Autonumber primary keys, and the child table has parent ID foreign key to the parent table. Now we want to combine all this data in the target database so that it would continue to hold both original target parents with their children, plus one more source parent with his children. And since we use an Autonumber primary key, the expected data in the target table would be like this. Source parent got the next available ID of 3, and this means that source children would have to use this ID as well. We're not going to discuss why we need to do this. It can be a bad design for a multi-database system if data needs to be combined, or that we need to use UUID data type instead of autonumbers or something like that. We love to dream about the ideal world where we design the perfect software from scratch, but in the real world it can be just some urgent task, or a one-time data migration, or a set of legacy databases that are not available for redesign. Sometimes we just have what we have, and this needs to be done with autonumbers. The video is divided into 3 parts. Part 1 with explanation of how this task is solved in our KSDB merge tools and basic demo of merging a few rows from one parent-child tables pair. Part 2 with more complex demos of merging multiple tables. And Part 3 with discussion about benefits, limitations, and future plans of the suggested solution. So, we're going to talk about the solution that was recently implemented in the KSDB merge tools. We have called this feature Id-Remap Merge. This video can be used as a tutorial for Id-Remap Merge, or it can provide you with some ideas of how such a task can be solved in your own custom solution. All the examples in this video are performed using the KSDB merge tools for SQLite, but that's done just for the sake of speed and simplicity. Exactly the same logic is implemented for almost all of our tools, for Oracle Database, for Postgres, for MySQL and MariaDB, for MS SQL Server, and even for cross-DBMS scenarios. As we can see from this slide, each tool has a logic related with a DBMS-specific Autonumber implementation. Okay, let's proceed with our basic example. Instead of a parent and child tables pair, we're going to use another pair of tables which are part of the larger database model example. This model is also going to be used for the second part of this video, and the same model is used for our documentation. If there is something hard to read on this slide, you can find the same model in our online documentation for Id-Remap Merge dialog. Let's take a closer look at these two tables, product and product log. Primary key of the product table is an Autonumber, and this key is used as a foreign key for the product log table. And now let's switch to the demo. Here we have the KSDB merge tools for SQLite with our source and target database pair open. Let's check definitions of our tables. We can see that the product has an Autonumber primary key on product ID. And product log also has an Autonumber primary key, and it has a reference to the product table by product ID. Let's take a look at the product data. Here we have a picture very similar to our parent-child example. In both databases, we have a product ID of 1, named Common Product, and in our example, we assume that it is a product entity which exists in both databases and does not need to be merged from the source to the target. In each database, we have 2 more product rows, source-only products and target-only products. And we assume that we need to merge both source-only products to the target database. Let's take a pause and tell a few words about these colors and numbers and general terminology used by KSDB merge tools. By default, KSDB merge tools compares tables using the primary key. If the same key value exists in both databases, then such a row is considered as the same row. Depending on values of other columns, this row can be considered as changed or unchanged. Our common product with ID of 1 has the same name in both databases, then it is counted as unchanged and highlighted in white. Product ID of 2 has different names, then it is counted as changed and highlighted in red. Source product ID of 3 does not exist in the target, so it is counted as a new and highlighted in green. The same for product ID of 4 in the target database. It is also worth mentioning that using this terminology of new and changed rows by ID values, the Id-Remap merge is almost always increasing the amount of changes between databases. That's because these two source product rows will have to get the next available IDs in the target database. In the general case, these new IDs will not be the same as in the source database, and this will make imported rows to be counted as new or changed, depending on whether the same ID values are already used in the source database or not. Now let's open the product log table, and we see that there is one row related to the source-only product 1 with product ID of 2, and two rows related to source-only product 2 with product ID of 3. There are 3 rows total that need to be merged. Product log ID is an Autonumber, so after merge, all these source rows will have to get IDs starting with 7 and higher, and product ID values will have to correspond to the new ID values of source-only product rows in the target database. Now, let's go back to the product data, select our 2 source-only products, and perform a merge. Application defines that it is a table with an Autonumber primary key that is used by foreign keys, and suggests to do the Id-Remap merge and explains what can be wrong if we don't do this. We agree to use Id-Remap merge and click OK. Application analyzes foreign key dependencies of our product IDs and lists here our product table and all its child tables, and asks us to select what tables we want to merge. That's our first list of tables. Application also shows one more list of so-called other parent tables, but this is out of scope of our basic merge scenario, and we ignore it for now. So, looking only to the first list of tables, we can see 2 interesting things. The first thing is that there is not only product and product log, there are also order item and order log to order item. The second thing is a DL column. To understand why it happens, let's go back to our database diagram. Here we can see that product ID foreign key is used not only for product log, but also for order item, and that order item has order item ID Autonumber primary key used by order log to order item foreign key. That's why we see these tables in the Id-Remap configuration. Now let's talk about DL. DL stands for dependency level, or table foreign key dependency level. That's something that was introduced by KSDB merge tools some while ago to help with merge of changes in correct order to avoid errors related to the foreign key constraint violations. In our example, tables user, client, and product have no foreign keys, so they have DL of 0. Tables order and product log depend only on tables having DL of 0, so they have DL of 1. Tables order log and order item have DL of 2 because they depend on tables with DL of 0 and 1. And lastly, the table order log to order item has a DL of 3 because it depends on tables with DL of 2. DL is very important for Id-Remap merge implementation. We need to process tables with lower DL first and get Autonumber IDs of inserted rows, and only then use these IDs to insert into foreign key values for tables with higher DL. Now let's get back to our demo. For now we need to merge only product and product log, so we disable order item. Order log to order item is disabled automatically because it depends on order item. The dialog says, to have consistent dependencies, the following rules are applied, and we can see that the unselected parent rule was applied here. As we discussed earlier, we don't touch the other parents list. This will be covered in part 2, and we don't check the remove mapping tables option because the result of our merge will also be used in part 2. So we click OK, and here is our script. Application shows and executes script statements one by one. We can do the copy all or save all to get the whole script. Now, let's scroll through the statements and check what we have. The first script creates mapping table to keep mapping between source and target IDs for the product table. The next statement does the same for product log. The next two statements insert our source product rows to the target database. Script does not specify the primary key. It is auto-generated. And right after insert, we populate our source ID to target ID mapping for that row. The last insert row ID function is specific for SQLite only. KSDB merge tools for other database management systems use other ways to populate mapping. For example, a tool for SQL Server uses insert output into statements. And the last three script items are used to populate the product log table. The same as for product, we do not assign the product log ID. Insert will use the Autonumber. Instead of inserting product ID of 3 from the source, we insert target ID from our mapping corresponding to that product ID of 3. And, what's also important, our script includes only product log rows for selected products. It does not include product log rows for a common product that was not selected to merge. Well, let's check how it works. We've got two source-only products in the target database with IDs of 5 and 6. Let's open product log, click refresh, and we see that there are 3 new rows, 1 for product ID of 5 and 2 for product ID of 6. We can check the product data again and see that the new product log table rows correspond to correct product table rows. That's it for part 1. See the rest in parts 2 and 3 if you think you need more of Id-Remap merge. Thanks for watching.